Hi students. So today we are going to see the topic on principles of survey. Objectives. On completion of this topic, you will be able to understand the principles of survey. So in the previous videos we have seen surveying of definition of concept of survey, and the types of surveys, and what are the uses of surveying we have seen. Now we are going to see the most important topic, that is the principle of surveying. So actually what is the principle of surveying? That means in the principle of surveying the work will be done from whole to part. So let us see it deeply. So in the previous class we have discussed the classification of surveying based on instruments. So now let us see now principles of surveying. So there are two basic principles of surveying. One is always work from whole to part, and the next one is to locate positions of any new point with reference to any two known points. So let us we explain the first one very clearly. So this is a very important question in the examinations also. So wherever you go, if you do the survey, this principle must be followed. Okay, always work from whole to part means if you start the survey in a day, which is the starting point, and up to the completion of the survey work or project, that is called whole to part. So we will be starting the project from always work from whole to part. Meanwhile, in the to locate positions of any new point with reference to any known points. So if you want to locate the points, just like for example, if you want to locate the any other 2 points on the ground level, so first we need a reference point. So that is a benchmark or any other chainage level. So from that reference we can locate the points on the ground also. So this is the principle. Let us see here first what is actually always work from whole to part. So here you can see this is the chainage diagram. So we will call chain triangulation survey also. So in the principle of surveying we can see there are different lines are also there. So once you can see this outer portion which is there, this is the ground level, which is the boundary line. So this is the boundary line of a part. Okay, boundary line of any area. In that we are dividing these triangles. We are dividing these triangles into number of parts, just like A, B, C and ACD. Okay, same like that another triangle also divided, that is from BCE, and in BCE you can divide the some other points also, that is G, F, H and J, K, L. Okay, here we are having the line names also. One is called baseline, another one is called check line, and another one is called tie line. So in this we can see the outer lines which are there, the triangles, those are called the baselines, and in between the intermediate which are there, those are called the check lines, and the adjacent points which are meeting at the point, those are called the tie lines. So regarding these lines we are going to study in the upcoming classes. So here the surveyor should establish accurately large mainframe work consisting of widely spaced control points A, B, C, D and E. So in the diagram you can see where is the A, B, C, D and E. So let us change the color so that we can identify it very clearly. Yes. So where is the A? This is the A and B and C and D and E. So these are the 5 points of the border lines. Okay. So from these we will be determining the another points. So whatever we have started the survey point, that will be the starting point is A. So from this we have to set the object to the B, and here you have to keep a point, and next after from B you have to set to the C, then here we will be keeping the point. That means where we are keeping this point at the edge of the ground level, the borderline which is there we are taking the at the edge, and after C again we are taking it to the D. So again from D you will be cross section to the A. Okay. So then after C here, from C to E we will be taking the point, and after E again E to the B, so that we will be getting the triangular points. So when we get these triangular faces, but how we will get this triangle? By seeing with the ranging rods. Okay, with the ranging rods, with the help of the dumpy level or auto level instruments, we will be locating these points on the ground, so that we will be taking the points and locating the surface. So with the help of, here suppose you see the two known points have got, that is A and B. So keeping the chain from A to B and keeping the another chain from B to C and A to C. So adjoining these 2 points, okay, suppose AB is equal to 30 meters, then BC and AC should also be 30 meters. So at that the point will be meet. So that is in the triangular portion. If sub not taking the a point on the border lines, okay, so then we will be locating the AC and BC points. So meanwhile like that, now this large framework is to be divided into large triangles ABC, CDA and BEC. So what we have done, that is the making it the triangles. So after taking these triangles, and we have to calculate the with the triangle formula and hypotenuse formula the areas of the each section. The next, the large triangle BEC is further divided into small triangles, further subdivided into still smaller triangles, because to know the area clearly we will be dividing the large triangle into small triangle, and if it is not conveniently more, the small triangle is divided into more small angle. And interior details in these smaller triangles are surveyed with less accurate methods. So here we will speak this with the less accurate methods. So these details will be seen in the smaller triangles also. So this avoids accumulation of errors. So this one will be accumulation of errors. By doing these principles of surveying from whole to part, so we can avoid the accumulation. And if the survey starts from smaller triangle JKL, the errors get accumulated during extension of survey. So where is JKL? Let us see. So here this is J and K and L. This is a smaller triangle. So when this smaller triangle, if the survey starts from smaller triangle JKL, then the errors will be get accumulated during extension of survey. So what is saying here, if you start from the JKL, then the errors will be, that means you will be getting the extension of survey, more the survey will be extended. So that's why we have to count from the outer of the boundaries. If any is pending, that will be closed in that area only. So if you start from the center of the part, it will be extending on survey, and hence survey is acceptable from whole to part. The next, to locate positions of any new point. So if you want to locate the position of any new point on the ground surfaces, the new point may be located, that is with reference to two known points. Okay, so that is regarding any, if you know the two known points, then we will be locate the positions of any new point. That is either by linear, angular, or both the linear and angular measurements. So this is with the location of positions. So we will be locating this one either by linear, angular, or both the linear and angular measurements. So what is the here linear and angular measurements? The linear measurements which are taken with the chain and a tape, those are linear. But coming with the angular measurements which are taken with the instruments, just like compass and theodolite instruments, are known as angular measurements. So let us see here ABCD. It is of 90 degrees. So let A and B be the two known ground positions. So these are the two known ground positions. Okay. But point C can be located by the following methods. So what is this method? It is the perpendicular method or crosstalk method. So by knowing the A and B length, keeping at the center point D, then we can extend it to the C point perpendicularly with the help of 90 degrees. Then you will be getting the point C. So that from C you can extend it to the A, and you can draw a line to the B. And by linear measurements, AC or BC and the perpendicular distance CD. Next, figure 3. Here by two linear measurements, AC or BC. So this is AC or again BC. So this is known as the knowing the two lengths. AC is equal to BC, AB is equal to BC, BC is equal to AC. Another one, this is by angular measurements beta and linear measurement AC. So you can see there is no angle between A and C, but there is an angle between C and B, that is termed as beta. So this is called the angular measurement. And another one you can see by angular measurement alpha and linear measurement AC. So this is the angular measurement alpha and linear measurement is called AC. So here both are there, linear and angular measurements. Whereas BC will be also in linear measurements. Next, figure 6. Here by two angular measurements alpha and beta. So AC is one angle and BC is another angle. This is termed as alpha and beta. So AC is equal to BC, BC is equal to AB. The next, the following points may be noted while performing surveying. So this is the important question. So while you are performing the surveying, there is a requirement. So that is, the cost of survey increases with an increase in accuracy as follows. If less accuracy is sufficient, chain survey can be adopted. So what is the accuracy here? Long distances which are cannot see with our naked eye. Okay, so that means here, if the accuracy is sufficient, only if you can see with your eye the clear object, then only you can do the chain survey. That means this chain will be length will be the 15 meters and 30 meters. So up to that 30 meters you can measure, and if the more length is required, you have to join the chain. And if more accuracy is required, then steel tape can be used. Okay, so the chain survey will be the 30 meters, but if more accuracy is required, compulsory we have to do the more length of the survey, then we have to go for the steel tape for measuring the length. And if still more accuracy is required, then instruments like compass or theodolite are to be used. So averagely our eye can see up to 1,000 meters or nearly 500 meters or 400 meters length approximately clearly. But more than that, our eye cannot see the objects clearly. So that purposes we need the instruments, that is theodolite, compass, dumpy level, etc. So that's why we should be follow the points compulsory. So less accuracy, more accuracy, if still more accuracy, then there is always a possibility of making errors while taking the measurements and recording the observations. So we can see here there is always a possibility of making errors. When we are taking the measurements, we will be having the errors. So that is, generally while taking the measurements, we can record the observations. And hence, there should be suitable provision for checks. So whatever the measurements and lengths we are taking, we should be checked and we should be measured, and it should be recorded in the table book performance as per the survey. And all the measurements taken in the field must be recorded in a proper field book at the time of measurement itself. So whatever the measurements we are taking in the field, that must be recorded in a proper field book at the time of measurement itself. Otherwise, the readings will be changed, or anything mistakes will be happen, or if we forgot the readings, so that will be problem. So that's why when we have taken the measurements itself in the field only, it should be recorded in the field book and the calculation should be done. And it should be neat and clearly written such that others can plot from the field data given. So that means it should be neat, that whatever we are writing with a pencil or pen, we should write clearly and neatly, so that the field which are corrected, it will be in the correct measurements. If anything wrong where mistake happen, then it will be corrected from the data. The field book is the original record of data and it should be kept in safe custody. So this is a field book here. Whatever we are doing the surveying measurements in the field, we will have the field book. So this is related with the engineers. So in that field book we have to record the original record of data and it should be kept in the safe custody. After that we can take the measurements if required, or if any changes can be done from the field book itself. Okay. So finally, let's see the important points in the field book. So this field book will be generally available with the civil engineers when they are doing the surveying. And that's you can see as per the measurement book also will be there while taking the levels. So let us see now the another topic, that is change survey. So in this topic we are going to see purpose and principle of change surveying, equipment used in change surveying and their functions change. So let us see objectives. On completion of this period, you will be able to know purpose and principle of change surveying and different equipments in change surveying and different types of change. So we have seen in the previous classification of surveying and purpose of surveying and fundamental principles of surveying and classification based on instruments used. So purpose of change surveying, what is the purpose? So we have seen the purpose of surveying, but now we are going to see the purpose of change surveying. What is the change here? Have you over have you come across change surveying anywhere? Have you seen anywhere when the surveying is going on? Now let us see the purpose of change surveying. So purpose of change surveying is to take linear measurements in the field by chain. So whatever the measurements we are taking with the chain, we will call it as linear. Remember this word, we are taking the linear measurements, that is measuring the length. And remember, no angular measurements are taken because here we are using a chain for the measurement of lengths. So that's why there is no chance of angular measurements. So principle of chain survey. So in this we are going to see chain triangulation, arrangement of framework of triangles. What is chain triangulation? So a ground surface is like this. In that, making the different angles with the, just like making the triangle. So these are known as the chain triangles. So nothing but any area which is divided into the number of triangles is called chain triangulation. And here measuring the lengths. So after making it into the number of parts, then we will be measuring the length. And next we will do the plotting. What is plotting? The measurements which we are taken on the field, that will be drawn on the drawing sheet or any paper. So that is called plotting. So this plotting will be done with the help of our drafter. We will have a drafter scale, okay, and we will have a pantograph also. It is a minor instrument used for the drawing of plants, enlarging and reducing. So the plotting will be done, and the error in plotting a triangle is minimum when no angle of triangle is less than 30 degrees and more than 120 degrees. So here when we do the plotting in the triangle, okay, suppose you see this, the triangle is there. So you taking this triangle here, minimum when there is no angle, it will be less than 30 degrees, okay, but not more than 120 degrees. And such triangles are said to be well conditioned, okay. So that's triangles are said to be well conditioned triangles if not more than 120 degrees and less than 30 degrees should be there. So what is the suitability of change survey? So it is suitable when ground is fairly level. So means ground is flat, okay, without any obstructions, it is clear. So that is called fairly level, and it is open with simple details. The ground should be open for the surveying for taking linear measurements easily, and plants required in large scale. So whatever the measurements we are taking, so that for that plans should be required in the take conversion into the scale. So that will be drawn into the maps, and the area is small in extent. So the area will be the small in extent, and it is not suitable for large areas. So remember one thing, for large areas then change surveying is cannot do, because this length will be small, so that's why we cannot do. And areas with crowded with many details. In chain triangulation we can see the areas which are there, the all details which are entered with many crowded, and difficult or wooded country. So it is difficult or wooded country to use the chain. So the next equipments used in chain surveying. So let us see what are the equipments are used in the chain surveying. The first one is called chain. Next, tape, ranging rod, crosstalk, arrows, pegs, plumber. Remember, this is a very important question. In exams, he will be asking what are the equipments used in chain surveying. One is chain. This chain will be of 20 meters to 15 meters and 30 meters. And this tape also will be 5 meters, 10 meters, 15, 20, 30 like that. So in the tapes are also we are having different materials. One is steel tape and the another one is cloth tape. And these ranging rods will be just like straight. So they will have sharp edge at the edges. So they will be coated with black and white, red and white color. So they will be a height of 4 meters. And arrows. The arrows will be like this with a hinge. So they will be using in the ground levels for keeping the points, and pegs. So the pegs will be of iron or wooden. So they will be just like a pencil type. So with a, uh, large thickness. So these pegs can be kept at the center point of the instruments or determining the points. And plumber. So the plumber will be like this. So it will have a thread, and it will have an aluminum bar small hinge. So this plumber is to check the center point on the distance or any instrument circle. So these are the instruments, equipments we have used. Here you can see the chain. This is called the chain diagram. This is our actual chain. So these two are called, you can see, the hand bracelets. These are the hand bracings which are there. The edges of the points are called hand bracings. These are of coated with aluminum and zinc, and it is also prepared with aluminum. So these are ranging rods, you can see. So these ranging rods we can kept on the ground levels, which are colored with red and white, so that at the far distance also we can identify these ranging rods with the help of this color. So here you can see the component parts. This is called brass handle, and we are having a ring. For every 0.1 meter we will have a ring, and for every 5 meters we will have a tally. So this is the 4 mm MS wire. MS wire means mild steel wire. So this will be of 4 mm thickness mild steel wire. So this is called metric chain, and in chain also we are having the 5 types of chains. So we should catch the chain at the edges of this portion at the left side and right side. So this one is steel tape. Here you can see steel tape. So this is the steel tape. So when we rotate with this tape, it will be going inside. So this is arrow. Normally arrow which is of, this is also made up of 4 mm thickness ms mild steel. This is also 4 mm thick mild steel, and it has 15 mm normal. The tooth of these edges of the sharp will be 15 mm, so that easily they can enter into the soil. So this 400 mm plus or minus 5 mm it will be. This is called arrow. And the next one is ranging rod. So here you can see the ranging rod. It is coated with white band color and red or black band color. So this is of 0.2 meters height. At the edge we have 0.15 meters. The total height is 3 meters. So this is our ranging rod, and the next one is offset rod. This is offset rod we call. So it will be of length measured 1 meter, 2 meter, 3 meters. So with the help of these ranging rods, we can see the we can make the chain into straight line, and we can see with the naked eye also. So we can do the ranging also, the line ranging and making it into a straight line. We can determine the boundary points also. So let us see the chain. In this class, let us limit our discussion to chains now. So function of chain is to measure the lengths. So only this chain can be do measuring of lengths only. So it consists of galvanized mild steel wire of 4 mm diameter. So it is of generally galvanized mild steel wire of 4 mm diameter. And this chain have links. Each link will have 3 rings. So in each chain you will have the 3 links. For each link will have 3 rings, and it consists of 2 brass handles at either end. So one will be the one end and another will be the other end. So these 2 handles we have to catch. Those are called brass handles. Here we can see this is the one end, and another end also will be same like this. So this is a metric chain. And description of chain. The length of the chain is the distance between the outside of handles. So the chain will be the more than the distance length. So we have to take the length of the chain is the distance between the outside of handles, and the length of link is distance between the centers of middle rings. So here it is the length of link is the distance between the center of the middle links which are there. So between them it will be the length of link. Brass tacks or tally is fixed at regular intervals. So in between links we will have the brass tacks, and a tally will be there. So it will be showing the up to 5 meters and 15 meters, that is known as tally. A ring will be attached at the link. Next let us see the types of chains. So what are the types of chains are there? A metric chain, engineer's chain, Gunter's chain, revenue chain, steel band or band chain. So we are having the five types of chains: metric chain, engineer's chain, Gunter's chain, revenue chain, steel band or band chain. So generally we are using in the surveying now metric chain. So no other chains are using in the surveying. So this metric chain, it is available in 20 meters or 30-meter lengths. So it consists of links each with 20 centimeters, that is 0.2 meters length. So it is consists of links, that is for each 20 meters we will call it 0.2 meters length, and 20 meters chain have 100 links and 30 meters chain have 150 links. Remember this one, very important topic. So in 20 meters chain we will have 100 links only, but whereas coming to the 30 meters chain you will have more other 50 links extra. So there are tags are fixed at each 5 meters intervals. Just now what I said, for every 5 meters we will be keeping the a tags will be there. So these tags determines the 5 meters length intervals. And small brass rings are provided at every meter length 24. These are small branches are provided every meter length. Next is engineer's chain. So this engineer's chain, it is of 100 feet length. This engineer's chain is 100 feet length. So whereas comparing with the metric chain is only the 20 meters and 30 meters length, but here engineer's chain is 100 feet length. And it is provided with 100 links each of 1 feet length, and it is used for engineering surveys. So the distance measured are recorded in feet and decimals. So we cannot take it in the meters, but later we have to convert. So that's why here the distance is measured in the feet and decimals only. Next one is Gunter's chain. So this is used measuring the land in acres for agricultural purposes, and it is of 66 feet length and provided with 100 links. So this Gunter chain is used for measuring the land in acres, just like in agricultural fields you will be using this Gunter chain, and it is of 66 feet length only. It is provided with 100 links, and each link is 0.66 feet. So here 10 square Gunter chain is equal to 1 acre. The next one is revenue chain. It is 33 feet long and provided with 16 links. So it is generally 30 feet long and it is provided with 16 links. So the length of each link is 21 by 16 feet. So it is the length of each link, and it is mostly used in cadastral surveys. Next one is metric chain. Here you can see this is a metric chain. how it is there. So the details of metric chain was given. So this is a 5 meters. So for every 5 rings, it is mentioned here. You can see the 5 meters, and this is called the tally. Okay, tally is provided here, and this is called the eye bolt, and this is called the collar, and this one is called the handle. This is 6 dia, and this is called groove at the edge groove. It is of 2.25 radius, and this is called the ring, which is connected to the brass handles. So nothing but this is a metric chain we can see. So next is steel band or band chain. So steel band or band chain, it is a steel ribbon of width 12 to 16 mm. The length may be 20 or 30 meters, and it is divided by brass studs at every 0.2 meters and numbered at every 1 meter length, because to remember it will be numbered at 1 meter length, and it is used in high degree precision. So this type of steel band or band chain is used in the high degree pressure, means at the higher level works they will be used, and it is easily broken and difficult to repair. So this steel band or band chain is difficult to repair if it is broken. So this is called steel tape. So these steel tapes will be of 5 meters, 10 meters, 20 meters, 30 meters, and this is called cloth steel tape, another one. This is also a 50 meter steel tape. So finally in this class we have discussed what is chain surveying, principle of chain surveying, different types of equipments used in chain surveying, and different types of chains used in chain. Okay, so this is the regarding chain surveying. Thank you. Have a nice day.